So in the previous video, we proved that the derivative of e to the x is e to the x. So let's use that on this page. They want us to find the derivative of 3 times e to the x. Well, that's going to be 3 times derivative of e to the x, right? You can pull out that constant. Now, we've just been talking about how derivative of e to the x is just e to the x, right? So here's the final answer, 3 times e to the x. So look, exactly the same, okay? If it's just a constant in front of it, the derivative is going to be the same. So I can make up like hundreds of these questions exactly the same. Like let's say y equals 5 e to the x. Well, guess what? The derivative is 5 e to the x. If I say that y is equal to negative 85 e to the x, whatever the number is, the derivative is going to be exactly the same if it's just a constant in front of it, okay? Now, let's look at this one. Well, what do you think? If y is negative 5 times e to the x, the derivative is going to be negative 5 e to the x, exactly going to be the same, okay? Just because of this powerful rule that we proved in the previous video, okay? It's not always going to be this easy though. Let's look at some examples down here. We're using, well, they're saying using chain rule, and we will come up with a cute little rule after seeing enough examples, but let's do this. If I want to take the derivative of this function, I need to find the derivative of the outside function, okay, which is e to the 4x, but I must multiply this by the derivative of the inside function, and the inside function, I'm referring to the 4x. So what is the derivative of 4x? 4, right? So if you simplify this, what's the final answer? Y prime equals 4 times e to the 4x. Now, that's why, this is actually a hidden chain rule here, but I think you and I, as we take these similar derivatives over and over again, I'll give you an example so that you can see a pattern. Let's say that you have y equals e raised to the 5x. The derivative is going to be 5 e to the 5x. The exponent does not go down to 4x or anything. It stays the same, but this number just comes down to the front. Okay, one more. What if I give you y equals e to the negative 5x? I'm sorry, that's boring. Negative 3x. Well, what do you think that derivative is? That negative 3, this coefficient of negative 3 comes down to the front, give you negative 3, but you keep that exponential term exactly the same. Do not go down on the exponent, okay? So that's how you can find the derivative of these exponential functions. What about this? What about this? Well, the answer is going to be y equals, look, that 3 will come down, right? So you multiply that by 7, so you will get 21. Well, keep that exponential term exactly the same. You do not go down to 2x, okay? So similar examples, what if y is 5 times e to the 8x? Well, the derivative is going to be what number in the front? 40, but you keep that exponential term exactly the same, okay? So I'll give you a couple examples of these basic e to the x function and their derivatives here, but we'll continue looking at more on the next page, okay?